Alright, this next chapter we're looking at now is where you're combining random variables. You're adding them together or possibly subtracting them, and then what you do with those standard deviations. Now there's an example that I believe to be somewhat perfect, or two examples actually, that we'll look at that are actually from the study guide in chapter 6 that's been provided for you. First one, written right here for you. You get the weight of eggs produced by a certain breed of hen is normally distributed with a mean of 65 grams and a standard deviation of 5. That's per egg. What is the probability that the weight of a dozen of them, 12 of them, randomly selected eggs is between 750 and 800 grams? So the dozen eggs is what we're interested in here, with a mean of 65 per. So, as the Smartboard notes showed, when you have the means of random variables, and you want to know what is the mean of one random variable, down here, plus another one, and so on, plus however many there are, then you add all of those means together. So you'd add the mean of x, you'd add the mean of y, you'd add the mean of z, and so on, through adding them all. Now in this case, it's convenient enough in that the mean of each one of them is exactly the same, 65 grams. So we're going to add 65 and 65 and 65 and so on, all 12 65s. Which then produces just this. The expected value is, add them all together, which is there's 12 of them, so we just simply take 12 times that 65 to get 780 grams. Now go back to the probability question. It says, what's the probability that it is in between 750 and 800? Now I know when you look at this, you're like, well, how am I supposed to figure this out? And that's where you have to go back and read what problem the problem's been presented to you, and you have to be able to find this, and it's got to mean something to you when you come across that. You got to say, oh, it's normal. So then that means there's a normal distribution here, and I can use z-scores and, more importantly, normal CDF. That's what we want here. Now, in order to use normal CDF, okay, so I got the 780 here. Just figure that out down here. But I need a standard deviation. And how do I get that? Well, there you go. A standard deviation, in order to find that, what you have to find is the variance of each and add all those variances. Again, that's in the Smartboard notes. So we're going to add up all these variances. Now we're told that each and every egg has a standard deviation of 5 grams. So in order to now combine all of these eggs together, we have to combine their variances. So notice the 5 squared right there, because variance is standard deviation squared. So we take that variance, 25, 12 times, and we get 300. Now that's the variance of all 12. And so now once we've done that, then we have to convert it back to standard deviation again. So we'll take the square root of 300, which comes out to a nice pretty 17.32. So now we know the mean is 780. Now we know the standard deviation is 17.32, and we're asked between 750 and 800 grams. So what we're going to want to do is draw our normal distribution. Sloppy, put in 780. Then you'll have a standard deviation length that is 17.32. And it's asking for from 750 to 800. So that's a little bit more than one standard deviation, so somewhere right about here-ish. And 750 is going to be noticeably below one standard deviation. And I'm going to shade in my area that I'm trying to find, and I see that it's a fairly large area. So I should end up with a fairly big probability here. And then I'm going to go to normal CDF right now. I don't feel like messing around with getting the z-scores. And I'll put in my low value, which was 750. And I'll put in my high value, which is 800. And I'll put in my mean, which is 780, and my standard deviation is 17.32. And quite simply, I am just going to hit enter on that, and it is going to tell me what that green area is. And we got it down here. Came out to 83.43. In fact, let me do this so we can see it. 83.43, and I look at my green area that I have shaded here, and I say yes, that looks like it's about 83% of the graph. And then here is another normal graph drawn for you, so you can also compare. And there you go, that's it. I think the hard part of that problem was, in fact, I would say with almost certainty, the hard part of that problem was identifying that and knowing that you were going to draw this in order to solve it. So that's combining random variables. All right, let's look at another example now. Here's another example now where we're going to be combining random variables. There's going to be a slight difference, and actually that word is going to be difference. So we got an example that says Tom's score for a round of golf has a normal distribution with a mean of 110 and a standard deviation of 10. Forget what that capital N means. And George's score for a round of golf has also a normal distribution with a mean of 100 and a standard deviation of 8. Now, real quick, for anybody not familiar, 100 in golf is better than 110. So in other words, you're a better player if you have 100. The lower your score is, the better you are at golf. And it goes on, if they play independently, what is the probability that Tom will have a better, lower score than George? So now what we're actually interested in is the difference in their scores. Because in order to determine if Tom has bested George, then his score, which is an average of 110, needs to be lower than the average of 100 that George puts up. This is now a difference that we're interested in. We're interested in that, mean of x minus y. Now it works the same way. You're just going to take the mean of x minus the mean of y when finding the mean. So, one guy's is 110, the other guy's is 100. The mean of x minus y is, quite simply, 10. That really is all there is to it. There's nothing else to that. That's the mean difference in their scores. That is an ugly 10 I drew there, in fact, if you don't mind. Try that one again. Draw it a little bit more legibly. Hey, that was a lot better. Okay, simple enough. Now, we're told, and once again we see this normality thing come into play here, so we're going to have to find something on a normal distribution, and we're going to need a standard deviation. So we're in that same boat again. Let's get this standard deviation. But how do we do this? Because now the scores are the difference. Now, if you find the difference of the two scores, the standard deviation is not going to be a difference as well, because the standard deviation is a measure of the distance from the mean. So it's a distance. It has to be a positive number. It can't like delve into negative numbers or zero, or below zero, I should say. So how do we go about this? Well, if that's the case, that you're finding the difference, much like the previous problem we did with the eggs, you are going to get the variance of each variable, and you are going to add them together. You are not going to subtract them. It's going to be just exactly the same. So if we find the variance, we're going to add 100, because that's 10 squared, because that's the standard deviation. We're going to add that to 64, because that's 8 squared, and 8's the standard deviation. We're adding variances here to get 164, and then the standard deviation will be the square root of that. Here they are typed out for us. So we do indeed have our mean of 10, and now our variance was 164, so our standard deviation is 12.8. So now what to do with this? We've got a mean of 10, 12.8. We have to find where Tom will have a lower score than George. And these numbers are the difference in their scores, which is plus 10 in favor of, well, in favor of Tom, but that's a bad thing in this case, as golf scores are better when they're lower. So what do we do? How do we go about this one? Well, first of all, we got to ask ourselves, what exactly does it mean for Tom to have a better or lower score than George? What if Tom had the same score as George? Then what would the difference in their scores be? It would be 0. That'd be, they both have the same number, and you must subtract them both from each other, and you have 0. And then if Tom bests George, or has a lower score than George, then the number will become negative. So we need to find a z-score at which this is the case. If you look very carefully right here. And I understand when you read this part, you'll probably be a little confused, but the probability that x minus y is less than 0, so in other words, Tom won, he had a lower score than George, is the probability that my z-score is less than the standardized z-score, where the standardized z-score is right here. We're going to find that line, that 0 line, minus the mean, divided by 12.8, the standard deviation. I get negative 0.78. Can I maybe draw a picture of this? Would that help a little bit? Let's do this real quick. So we have a normal distribution, where this is the mean difference in their scores. This is 10. There's a standard deviation of 12.8, and I want to know where 0 is. So right here is negative 2.8, one standard deviation, and then 22.8 over here. So somewhere just inside this line right here is where the 0 is. And I'm interested in all of this, because all of this area is where Tom beats George. This is where the number is negative, so the lesser guy's score was lower. So manually color this all in. So that's what I'm looking for right there. So now I go back to this mathematics here, and I look what I have here, and I got a z-score of negative 0.78. That works for me. It was just less than 1. So now what do? Well, we're going to go normal CDF again, because normal CDF just makes life easier. And then, actually, let's get this guy out of the way. Draw this a little larger. Sorry about that. Clean that up a little bit. And yes, we could have used our calculator, and we used normal CDF, and it's somewhere off the charts over here, so we'll use a large negative number, or just negative 100,000, or whatever you want to do. And then 0 is that line right there. So I want the area in between that, and the mean is 10, and the standard deviation was 12.8. And we get an area of 0.2177. And yes, you could have just gone to the chart once you found out that z-score of negative 0.78 and found that 0.2177. But it works. That is the area, and there you go. A little bit confusing of a question there, but in the end, just push normal CDF and the such. But good news, anybody that watched this video, I can promise you I am going to put on our midterm as one of the free response questions this question. This one we just dealt with right here. This golf score question. So go you if you actually watched this video this time and took some notes and learned this, because you will definitely see it again.